Great, welcome guys. 10 a.m. on a Thursday morning after the party. Glad to see everyone's here, bright-eyed, bushy-tailed. Last day of a fantastic event, so hopefully we'll finish off on certainly a high note. So I want to start with just a brief, who am I? Who is Esri? So my name is Rex Hansen. I'm a product manager for our game engine SDKs, for the ArcGIS Maps SDKs for game engines, but also our native apps. So really preside over our dev tools for native and game engine SDKs at Esri. I work for Esri. Esri is the global leader in professional GIS software, services, and solutions. We're based out of Redlands, California, Southern California. I'm also based out of Redlands in that location too. Just a little fun fact, about 30 years ago, I was a student at University of Arizona. I was a biochemistry major. I was getting ready for a career in the medical industry. And I discovered along the way that I could map geospatial phenomenon elements in the environment, sort of biological elements and other spatial phenomenon. I could map that digitally. And not only that, I had the power of programming, power of engineering. So I combined really digital mapping and computer science, and I was sold, right? So I changed from biochemistry, moved to GIS, and then of course the best place to land in the 90s at that point was Esri. That's a great place to learn, great place to cut your teeth and really start working with a variety of products. And so I started at Esri almost 30 years ago. Been working with desktop, server products, moved over to client development, and worked on engineering, web, native SDKs and dev tools for years. Fast forward to 2016, and Microsoft released HoloLens. When they released HoloLens, the developer experience was founded on Unity, a game engine. And so myself and our dev lead, Adrian Mario, who's now the dev lead for our game engine SDKs, embarked on an effort to try and showcase how to introduce real-world data, geospatial data, in a mixed reality experience, or mixed reality invented by Microsoft at that point. And so XR hadn't become a thing yet, and so we built out a demonstration using Unity as a game engine to deliver a virtual tabletop experience that we demonstrated on a Microsoft HoloLens in 2016 in the summer at our user conference, which is every year, San Diego, in front of about 20,000 people. And that was the catalyst that really got everybody thinking within almost every industry that was using geospatial, right? AEC, defense, public safety, environmental science, natural resources. When folks saw that combination and that really in-depth use of 3D geospatial in a productive way, they were in. And so we decided at that point that we should embark on a way to bring really 3D geospatial to a game engine. Now at the time that was Unity. That was the development environment that was promoted for Microsoft HoloLens. Fast forward a few more years. Then in 2019, we had the pleasure of really meeting Epic Games, Unreal Engine, just across the street over here, actually Seattle Convention Center, about 5 years ago at Microsoft Build that summer. And so at that point, we got to meet a variety of different, just fantastic folks at Epic Games. We started with Craig Laliberte, Ken Pimentel, worked with the Sebs, Seb Miglio and Seb Lowe's. And then they introduced us to a host of other really talented folks at Epic Games, and that includes Albin, that we just heard from, as well as folks like Danny and a host of other folks. And we started working together. We started collaborating with Epic Games in 2019 and 2020. And that resulted in a product. We delivered a plugin to integrate the ArcGIS system with Unreal Engine. In 2020, we had a beta program that went out with about 7,000 users across every industry. And then about 2 years ago, a little over 2 years ago, we released our first plugin in production. And so here we are, 2024, my first presentation at Unreal Fest, where we can combine the world-class GIS and 3D geospatial from Esri with the premium developer experience that comes with Unreal Engine. And so I get the privilege and the pleasure of presenting what we've done thus far, working with Epic Games, working with our talented dev team at Esri, to build out developer tools so that software developers, engineers can really bring 3D geospatial to the benefits, all the capabilities that Unreal Engine provides. So a little fun fact behind the scenes, a little trail there for the last 30 years or so. This has been a long journey, but certainly a pleasurable one. So let's dive in a little bit. I want to do a little, maybe just a brief review of Esri and ArcGIS. It's a big system, so we're gonna take a couple slides just to talk a little bit about what that system is. Oop, there we go. Okay, first, Esri builds ArcGIS. So Esri Esri builds ArcGIS. ArcGIS is a complete 3D GIS system for managing and integrating all types of 3D content, really creating a platform for things like living digital twins. So we help customers across every industry gather, create, and manage authoritative 3D geographic data in a GIS, a geographic information system, a system of record. So customers then use that data to visualize spatial phenomenon. They use location-based resources, they establish associations, they analyze impact, right? They determine data flows, they better understand spatial and temporal patterns, and then they communicate and share those results and solutions with others so they can make better decisions. So this includes, of course, 3D capabilities, which continue to advance across ArcGIS, from advanced visualization to 3D editing and analysis like flood simulation, to supporting the latest 3D formats like 3D tiles. And finally, creating focused, immersive experiences. So we have hundreds of tools that allow you to extract features, look at them in a 3D setting across organizations. These capabilities are extensive and they're far-reaching for creating living digital twins. Now, I'm a product manager for the ArcGIS Maps SDKs, which includes our game engine SDKs, which are premium developer APIs designed to build focused client apps on our 3D platform. So I'm going to focus on creating immersive experiences. So immersive experiences are designed to drive deeper engagement and interactions with advanced 3D capabilities and seamless interactions. So ArcGIS powers 3D and XR experiences that allow users to explore and analyze spatial relationships in an intuitive way, designed to reduce the abstraction between the digital and the real world across a variety of devices for focused immersive applications. So what are immersive applications? Let's go with the definition. So immersive apps are applications that use technology and techniques to immerse the user so fully in an experience that they see it as if it were real life. So fundamental to these experiences is really a complete digital replica of the physical world. Now, to create these digital replicas, or digital twins, we need authoritative geospecific content. These immersive apps need to look and operate like the real world with photorealistic content, imagery, textures, and materials. But to really immerse the user, this content not only needs to look like the real world, but it needs to behave like the real world, using techniques like animation for people, vehicles, lighting, atmospheric conditions such as weather. And the experience and the phenomenon need to be modeled or simulated, often includes real-time information through connectivity to services or devices that are in the field. So why would you build immersive applications? What we found is that it increases engagement with digital content and the workflow with compelling lifelike experiences. Now, this enhances the retention of knowledge and skills due to the experience. This results in a greater understanding of the context as it reduces the need for abstraction between the digital and the physical world. And in the end, these immersive apps are really designed to improve decision-making as the experience is more realistic. So decisions can be based on a better understanding of the environment and the problem at hand. So what technology is used to build immersive apps? There's a lot of client technology that's out there in the web and the native space to build out 3D GIS and geospatial applications. But most, if not many, are using game engines. Why are they using game engines? Well, game engines have targeted gaming experiences. And so it was essential that they deliver high-performance, premium rendering of content with fast and fluid interactions to meet and compete in the gaming space. Of course, to build a more immersive and compelling experience, game engines also invested heavily in systems and APIs to simulate real-time interaction and movement in real life. Game engines also provide support for targeting a wide variety of desktop and mobile platforms, and most importantly, dedicated specialized hardware. So part of this next generation of immersive applications includes business use of headsets dedicated to extended reality workflows, such as devices from Meta, Vario, and HTC. So game engines are built to support the responsiveness, the frame rates, and the fidelity that's needed to power these experiences. And last but certainly not least, successful game engine vendors have existing developer programs and deep communities. So what is Esri doing to integrate real-world data and geospatial analytics with game engines so developers can build immersive applications? So we built the ArcGIS Maps SDK for Unreal Engine as a plugin to bring the power of ArcGIS to the industry leader in high-fidelity, high-performance game engine technology, Unreal Engine. In general, the plugin provides access to a geospatial canvas in both global and local coordinate systems, and access to ArcGIS services, data, and analytics. So this means streaming large volumes of geospatial data to the client as needed for visualization. Then Unreal Engine provides the photorealistic rendering, the lifelike special effects, the animation, the physics. Really what brings your scene to life, what brings your data to life. So currently the ArcGIS Maps SDK for Unreal Engine, it's free to download and develop. For those of you getting started, Esri's ArcGIS location platform includes a breadth of hosted data options. So with that in mind, let's take a quick look at how to get started. So this is just a quick 5-minute video of the process from download to dev. Just to make this simple, I created this in my room last night. So nice and easy, right? Keep the demo demons away. All right, so first we want to navigate to the Esri developer site and the ArcGIS Maps SDK for Unreal Engine product page. You can also get there from the Unreal Marketplace. So this is your go-to site for getting started with doc, resources, samples. We have a community to help in this place as well. You can also download the plugin from this site at no cost. Don't need to log in. We have a host of versions here. You can see our latest version is 1.6. Once we download the package, let's go over to an easy place to get started is using data hosted by Esri in your Unreal Engine application. Let's navigate to ArcGIS Location Platform. It's another site. You can sign up for free. And from this place, from this location, you can create an API key to access Esri hosted data. We'll use that in just a moment. Okay, so now we've downloaded the plugin. We've got an API key. Let's fire up Unreal Engine 5.4. And we'll create a new project using the games option. We're using a blank template. Be sure to select the C++ project type, give it a name to create it. We need to build it, build our plugin. To save time, we're going to fast forward past this creation portion here real quick. And then we're going to go to installing the plugin. Right, so we've downloaded the plugin, which is really a zip file. And so what we're going to do is we're going to go inside, we're going to go to the location we've downloaded, we're going to open up that zip file, latest version, this is 1.6. We're going to copy the ArcGIS Maps SDK folder. We're going to go to the project folder we just created. We're going to create a new folder named Plugins. We're going to paste the ArcGIS Maps SDK folder in. That's going to take a little bit of time, actually, so we're going to fast forward again here. So we'll go inside Plugins, we'll paste in the folder. It's going to take some time. All right, so we'll fast forward again, and then we'll open up the Unreal Engine 5.4 project. Note, we'll open up the Plugins dialog, and then under the Esri category, we'll see the ArcGIS Maps SDK for Unreal Engine plugin is listed. Now, fortunately, with the plugin, we get a set of samples that show you how to use things like the API, Blueprint, C++, user experience, integrated user experiences. We also support things like global and local scenes, virtual tabletop experiences. So we're going to open up the global scene example. We'll talk a little bit more about what these mean here in a moment. All right, we're going to go to the ArcGIS Maps SDK Modes panel UI. So this is a user experience that we've integrated within the IDE within Unreal Engine. And we're going to configure the ArcGIS map. So first we're going to use the API key that we got from the location platform earlier. We're going to paste it in. And now we should see our data in the level. There we go, so some data showing up. This is in editor mode. We'll see the data layers start to stream in for services hosted by Esri. So in this sample, we see things like buildings, terrain, and imagery. And then next, we'll take a look at the Modes UI panel a little bit in a bit more depth. So we'll take a look at the map option under the Modes panel. We can see options for setting global and local and origin location. We can navigate over to base map. We can switch between base map options hosted by ArcGIS Location Platform, accessible with our API key. See them update in the level at editor time. So change things like kind of unique styles like the colored pencil and the dark gray canvas. Great, we're going to go back to imagery. And then we can look under the layers tab here. We can see what layers have been added. So we have 2 layers. We have a demographic and tiled service. We also have the San Francisco 3D buildings. We'll turn off the demographic layer at this stage. The colorization is going to go away. And then next we'll play the level. So we can start to interact. We can see the data in our view at runtime. So this is going to include global elevation, global imagery, and 3D objects that represent buildings, textured buildings from San Francisco. Now, out of the box, we have components that allow for you to interact with this scene more effectively, so you don't have to build it yourself. So mouse and keyboard navigation is included, so we can move around the view. Now, this is about 30 gigabytes of building data, but it's in a service. We're only streaming what we need, those textured objects and tiles as we need it for visualization. You can see different cache levels pop in and out as we move, depending upon the bandwidth, connectivity. We'll see that perform a little faster or slower, depending upon that. So we'll see as we start to navigate around, we can see the imagery in the buildings emerge and show as we interact with the scene. This is really just one of a set of prepackaged samples that are included with the plugin, just to help you get started with some basics. We have a host of additional samples that are available in GitHub. Source code is available for those. I'll show a few of those in action at the end during our Q&A section in the background. All right, so let's talk a little bit more detail about the capabilities of the plugin. Let's dive into the details. So the Unreal Maps SDK supports a wide range of high-performance cached layer types. We'll start top-down with 3D content. So we support scene layers, which are founded on I3S. I3S is an open specification for the storage and delivery of massive amounts of 3D geospatial data in any coordinate space. 3D object scene layers represent discrete objects such as buildings. Building scene layers model the exterior and the interior of buildings and are derived from BIM, or Building Information Model data. It's often imported from other systems like Revit or IFC. They typically represent individual buildings or building complexes. And then there's integrated mesh scene layers. This represents a continuous surface, including the ground, buildings, vegetation. They're often the result of imagery that are captured from aerial vehicles. So all these layers typically have image textures built into the layer for lifelike rendering, or you can actually you have the option to color customize as well. Now, to provide geographic context, the SDK also supports base maps as either ArcGIS image or vector tile layers. So image tile base maps contain aerial or satellite imagery, while vector tile base maps contain topographic features. That includes things like streets, buildings, footprints. They can be stylized on the fly, or they can highlight specific features to provide maybe a high contrast daytime map or maybe a muted night base map. So we have flexibility with our vector tile base maps. Terrain or ground surface right now comes from an ArcGIS elevation layer, and this is comprised of highly compressed lurk encoded tiles with elevation values. Now note all of these layers are cached. That's designed to streamline the delivery of data, large amounts of data to clients, and really optimized for visualization. So let's talk a little bit about the data sources. So there's two patterns for working with geospatial data sources mentioned in the previous slide. One is services with cache tiles for elevation or base maps, or I3S caches for 3D content for connected workflows. And then two, as tile or scene layer packages, which enable your application to work completely offline. Those packages are created with ArcGIS products like Pro on the desktop, or they might be created through services or service endpoints that are hosted either by Esri or on your own enterprise. And when working with services, they can be public or open services. They can also be private or secure services. And in terms of working with secure services and authentication, the SDK supports two options, OAuth 2 and API key. So OAuth 2 enables you to build a sign-in experience for your application, where the user can identify as a member of an ArcGIS organization that could be on-premise or in the cloud, our cloud, and access their own content and content that's been specifically shared with them. Now, API keys enable you to bake in access to ArcGIS location services or your data that's hosted in ArcGIS Online or ArcGIS Location Platform. So a couple different options there on working with geospatial data. Let's talk a little bit about geography and physics. So to accurately place, render, and interact with geographic data at a global scale with proper precision, we needed Unreal Engine to support 64-bit double precision data. Now, fortunately, this was delivered with Unreal Engine 5, and thanks to Alvin and team. This provided the critical foundation for native geospatial placement, rather than placing data, or rather placing data using its true geographic coordinates. This was essential to being able to support true geospatial data. So we support a single spatial reference and tiling scheme per map. So for global scene or round Earth experiences, we support geographic coordinate systems. For local scenes or flat Earth experiences, we support projected coordinate systems. The exceptions are WGS84 and Web Mercator. They'll work in both global and local with some reprojection, of course. This is one of the benefits of working with our plugin, is it comes prepackaged with a projection engine that transforms between these coordinate systems effectively, so that all of your layers can really speak the same language and operate in the same space. So the Maps SDK also supports the ability to enable a mesh collider for all layers in the ArcGIS map. This means you can work more intuitively with surfaces, you can leverage physics, you can use ray casting to detect objects and intersections. And then lastly, we provide a full geometry library. It's a class called Geometry Engine. It includes fast, synchronous, fine-grained operations, so you can compare and manipulate individual spatial geometries. So one other common need with respect to real-world data is the ability to manipulate and refine geospatial content. So we include tools that work in the editor and at runtime to clip terrain, imagery, and mesh, and then if you choose, replace it with other more dynamic content, like higher fidelity custom terrain or 3D mesh models. We also support things like masking, which really only shows a portion of geospatial data, often used to focus on a specific area. What's great here is you can interact with these tools in the editor. So we looked at clipping, now we're looking at masking. We can interact with the tools and visually see the area within our scene that we want to be able to show, hide, or in this case, flatten, which means you can set an elevation for a mesh, such as a scenario where, let's say, the foundation of a building footprint for a construction site needs to be flattened in preparation for new construction. So note, these modifications are all client-side. They don't change the original source data. But with the client, things like mesh colliders are updated to ensure that raycast operations are still supported and honored. Continuing this theme, spatial filters. So spatial filters can remove structures in 3D object and building scene layers to focus on a specific area of interest, or more commonly to replace with other content, like assets from a 3D file like FBX or Datasmith or USD, or even other ArcGIS data sources like packages that might be coming from packages or services. So this is great for preparing an area for more detailed content. That content is often dynamic, and so the other data within the scene provides a context, and your dynamic data can be replaced with something a bit more, let's say a bit more modifiable or changeable. So you can include objects inside or outside of a polygon. There's flexible options for filtering and refining your scene. Again, we support this in both editor mode with blueprints and in the API at runtime. Sort of continue with the spatial filter theme again. Building scene layers, they show complex building information. They can be filtered to show component parts. So given the high level of detail in a building scene layer, you may need to filter parts of the building to only see the information that's pertinent for your use case. So for example, you may want to see only the parts of the building that are on the second floor, or you only want to show load-bearing walls, or maybe just the electrical system. So to support this interaction, we've introduced UI tools, and of course APIs. So UI tools at editor time, but APIs that allow for you to define and apply filtering to a building scene layer at runtime. So these filters give you access to the full structure of a building scene layer, including stages of construction, disciplines such as architectural, and categories such as walls, and custom queries, so you can filter elements based on their attributes, such as the material type or the manufacturer. So a lot of flexibility, a lot of functionality with being able to filter and focus on content within your building scene layers. And then lastly, 3D object scene layers include attributes that allow you to, or enable you to visualize objects in the layer in a more meaningful way. So we currently provide access to attributes and shaders. So you can write a custom shader, work with a custom shader to change how 3D objects are rendered. You can set materials on those objects, like textures or colors. This screenshot just shows buildings that are constructed before and after a certain time. So working with attributes, maybe date constructed associated with the building. This is in Lower Manhattan. Right, so a little housekeeping with system requirements. We support development on Windows and Mac OS. Familiar development patterns include the UI-driven experience, which we saw in the Getting Started video, and then also blueprints or a C++ API for a full developer experience. Also for really a better developer experience, we support rendering the map and the data at edit time, and we saw that in our Getting Started video as well. Now for deployment, while Unreal Engine supports a wide variety of deployment platforms, currently the ArcGIS Maps SDK for Unreal Engine supports applications that target Windows, Mac OS, Android, and iOS. Of course, if there's other platforms that you'd like to support, let us know. Actually, we like to entertain all opportunities. All right, and this one of these last slides before I dive into some examples. So for the low-code, no-code experience, we know this is an important trend in game engines, also in Unreal Engine, which is this no-code or low-code experience to get started. So I just wanted to highlight the UI pattern again. This is the Modes panel UI in Unreal Engine. We got a brief look at this in the Getting Started video. This Map Modes panel UI includes the ability to add a map to a level, set the type of map, global or local, set the origin of the map, set the camera. In this case, we can also set ArcGIS data layers. We can define where the data loads, like an extent. We can link this to a game engine camera. We can add layers and elevation. We can configure authentication. We can set up clip, mask, flatten. We have a lot of opportunities, a lot of options with our UI experience integrated within the editor workflows within Unreal Engine. Of course, this functionality is also available in Blueprints and C++, but the UI provides a nice, easy visual way to get started. All right, so some examples. So next I want to show some of the work that we at Esri have been doing and showcase some of the great work done by our partners and customers to solve some real-world issues and enhance their geospatial workflows. So I want to start with this first example. This is really a demo. It's really a proof of concept where we're combining a lot of different capabilities of the ArcGIS system, the ArcGIS Maps SDK for Unreal Engine, and the benefits of Unreal Engine to bring our scene to life. So we'll see the ArcGIS Maps SDK for Unreal Engine in action. This is a focused application. It's designed to showcase site selection and exploration of a new development in an urban area. So what are we looking at right now? This is an integrated mesh scene layer of the city of Christchurch, New Zealand. Now in this case, I want to focus on the Tauranga library. It's in the center of the screen. And we're going to use the modification tools and filter tools here to clip this area from the integrated mesh so that we can add a building scene layer, really building information model of the same library with more detailed information to our project. So we'll navigate to the Layers dialog. And to clip, we'll go to this is the UI of our plugin. We'll select the Layers tab. We'll go to the appropriate service. We'll open the Polygon tool. Right, we'll draw the polygon interactively to clip. We could even really extend that area to include the parking lot, so I can drag that polygon. We can see at this stage we're really removing integrated mesh. We can see the imagery below it. And then now we're going to enable a more detailed building scene layer. There we go. So we can see our more detailed building scene layer. But given this is a game engine, this is Unreal Engine, we're going to run this immersive application. We're going to see how we can bring our scene to life. Game engine assets, special effects, these were previously added and enabled in the project. And granted, with this extensive ecosystem of game engine components within Unreal Engine, these capabilities and assets really provide this wide range of special effects, right, such as atmospheric and weather systems, so you can bring more realism to your scene. So in this case, we're changing from a rainy day to a sunny day. We can see other assets like trees and streetlights and furniture in this scene. They're all coming from features that are in a feature service. These are actual geographic locations that are represented through assets, symbolized through assets that are in our game engine. And then we can animate, right? We can show those objects, those assets, those actors change within the scene. So we can provide a more realistic environment. So people in cars use game engine logic to simulate their movement through the scene. They use nav meshes derived from the streets to define viable paths. And then from this point, we're going to step inside the building scene layer, and then we're going to see this highly detailed rendering of building information, right? It's a foundation for other game engine assets like chairs and bookcases and lighting. We're going to go out the window here. We're going to finish our quick tour. We're going to go through the window, go back to the park, and then we're going to look back at our building. Great, so a quick tour of a really lifelike experience there with real world data. So this showed some of the UI, some of the capabilities of the Maps SDK for Unreal Engine, such as the ability to clip and remove mesh, bring in some more detailed BIM data from a building scene layer, and then use some actors and systems to bring our geospatial data to life. Really our whole scene to life, actually powered by Unreal Engine. All right, this next example, so that was a prototype that we built in-house within Esri to kind of bring all of these tools and all these benefits together. This next example really showcases an enhancement to an existing product delivered by Esri named ArcGIS Urban. So ArcGIS Urban is designed to streamline urban planning workflows around the creation, analysis, and impact for urban areas. So our ArcGIS Urban team is enhancing their product with an immersive XR experience built on the ArcGIS Maps SDK for Unreal Engine. So the key here is they chose Unreal Engine to power this intensive, high-fidelity experience to enhance the urban development experience. So let's take a look. All right, so first our customers can author an urban scene in a browser with building, terrain, imagery, other realistic models, things like vegetation or furniture. And then they can choose to visualize it in an XR headset, in an XR application. First, they can choose a virtual tabletop experience. They can emulate this small-scale urban scene with attributes and information from geospatial content at the ready. Or they can view the scene at full scale, at ground level. Then they can explore their digital world individually. They can change textures. They can make it look more realistic. But they can also use this application to collaborate with another colleague in the same space. At the same time, they can see an avatar that represents others in their scene for greater awareness. So customers can also create presentations with multiple slides that represent different focal points or perspectives within the immersive scene, whether in a tabletop view or at ground level. Now this creates really an effective immersive tour of points of interest. And what's great about this is then they can present it in a collaborative VR environment for stakeholders and other decision makers to review from the same perspective, even when those individuals are remote, not physically in the same room. So definitely a powerful experience for use in production by urban planners, built on Unreal Engine and ArcGIS. So we should see a beta of this product come out really soon, hopefully by the end of the year. So some interesting proofs of concept, demonstrations, then also applications that Esri is working on with Unreal Engine to really deliver some of these, the capabilities of Unreal Engine, bring it to life for our users across industries, but specifically in that space, focusing on AEC and urban planning workflows. So next I want to focus on a customer project to build a focused immersive application. So in this example, the St. Louis Development Corporation worked with Halcyon Levine. Halcyon Levine's an Esri partner. They built a project based on an economic justice action plan to start building an interactive digital twin that the mayor of St. Louis could showcase. So they picked a neighborhood called the Ville. It's very rundown, but it's very historical, just north of downtown St. Louis. And the city purchased buildings and vacant parcels in the Ville along Martin Luther King Boulevard with the idea that they would build a new campus for workforce training across a number of industries. So the name of the campus will be the Monarch on MLK, a symbol of transformation and rebirth in that neighborhood. So the city and Esri provided data, local architects in St. Louis provided models of future structures. Halcyon Levine used ArcGIS City Engine to ingest, refine, and render structures, and then publishes ArcGIS services. The project needed more than just a simple display of as-built and perspective designs. They needed something compelling. They needed something animated, lifelike, immersive, and interesting. It needed to be something that could generate production quality media, screenshots and videos, something that resonated with decision makers and community members to get them excited and invested. So Unreal Engine was their tool of choice to deliver this focused app with compelling visuals and an interactive experience. They used ArcGIS Maps SDK for Unreal Engine to access multiple terrains, base maps, surrounding structures, and they leveraged the clip and mask and filter options, which were critical to ensuring their ability to add custom buildings and vegetation assets. So this video shows the players a Monarch, an homage to the name of the campus, who can navigate through the scene. They can see new structures emerge from the ground to showcase renewal. This solution is really invigorating the digital twin effort in St. Louis. So the city intends to continue building this app as a planning tool over the long term as they add more development projects going forward. It may even act as an example or really a catalyst for other cities seeking to embark on a similar effort. Data curated and hosted by Esri technology, visuals powered by Unreal Engine, and an ArcGIS Maps SDK providing the essential connection between the client and their GIS data. Okay, and we're going to finish with our examples with a beautiful showcase. So Port Coast is the primary design and engineering consultant for waterways and ports within the country of Vietnam. They deliver services, software, and hardware to map ports, maritime structures, and coastal areas for national and municipal governments within the country, including the Vietnam Ministry of Transport and the Department of Planning in Ho Chi Minh City. And their success is really expanding across the region. They're using a full suite of Esri products, including ArcGIS Pro, City Engine, Online, Enterprise, as well as apps built with our ArcGIS Maps SDKs for web and native applications. This is part of a sizzle reel of sorts, showing off some of the innovative solutions they've built, part of which focuses on XR and game engine technology to deliver high-fidelity, intelligent cartographic representations of their extensive geospatial data resources, really their digital twin. So recently, project requirements demanded custom, immersive desktop and XR headset experiences, and they're an Unreal Engine shop, right? So they have experience working with Unreal Engine, so they started with the ArcGIS Maps SDK for Unreal Engine to provide the geospatial canvas and then bring in data from the ArcGIS system, from their GIS, their world-class enterprise GIS. So this video shows some of those efforts in progress. Notably, we've seen a VR experience for local officials to visualize new construction or renovation. They're also building out projects to track and model traffic flows near ports, and really apps to simulate ship navigation and port procedures. Now, one of their latest projects involves acquiring bathymetry and subsurface structures for inland waterways throughout the city using submersible drones to be able to detect changes and potential problems over time. And so not just once, but continually analyzing and retrieving information to be able to monitor a near real-time digital twin. They're also looking at and working with the ArcGIS Maps SDK for Unreal Engine to deliver a dashboard to show this progress, to explore and deliver alerts, right? So really the takeaway here is that in order to grow their business and be successful, they needed a robust GIS, they needed methodology for gathering and overlaying multiple layers of geospatial data, and they integrated that with sensors and systems to bring it to life for this compelling, intuitive visualization delivered by Unreal Engine and ArcGIS so stakeholders and policymakers can make better decisions and clearly see the value. Great, so with that, let me talk a little bit about the roadmap for the ArcGIS Maps SDK for Unreal Engine. So, like I mentioned before, our first production release was about 2.5 years ago, 2022. The dev team has been actively building and adding functionality, supporting new data layers, supporting new capabilities. We saw some of those today. So this is an active development effort. We're growing the team. We're going to continue to expand capabilities within the ArcGIS Maps SDK for Unreal Engine. This is just kind of a look at 2025 and beyond. We release 3 times a year, generally every April, August, and November. And if we look at our first release in 2025, we're targeting a few key capabilities. The support for 3D tiles out of the box, both through services and local packages. Support for Vision OS, for Vision Pro. We're also looking at support later in 2025 for things like feature layers, working with dynamic vector data that's coming from the ArcGIS system, and then also expanding our support for different 3D types like point cloud scene layers. As far as capabilities go, we're really evaluating options for being able to refine capabilities within our plugin to be able to support resource-constrained devices, like really Android and iOS devices that have limited access to resources, so that we can optimize that workflow, so we're not pushing memory limits and really impacting the performance of applications. And so we're looking at options for being able to make that more flexible, more controllable. So really the takeaway here is that we're building out, this is kind of a word cloud of what's important right now. Now, what you're interested in might not be on this list. Let us know. This is a dynamic opportunity, a dynamic team, and there's dynamic options or capabilities within the system. So love to hear some feedback on what would be useful for you. Again, active development, we're just at the start of a long road here. So we're looking to advance this going forward for sure. And then sort of the last slide here, getting started. If you're looking to get started, there's a website. I showed it earlier in the Getting Started video. Here's a QR code that'll take you to that site to help you get started. Please look at the documentation that's available. There's a Getting Started page in there that enables you or shows you how to install, configure, get the API key, get the product, configure Unreal Engine to get it up and running. Software downloads are on the same site. Again, don't have to log in. These are free to download and develop. We have a set of samples in the plugin, but we also have a set of samples that are in GitHub. It's also available through this site. And then, like I said before, not only does Unreal Engine have a rich developer community, but Esri has a rich developer community. So our Esri community site is a great place to get help or assistance. Our dev team is constantly looking at, combing through, answering questions on our Esri community forum. Again, here too, there's a lot of capability, a lot of functionality, maybe even a lot of complexity actually in some of these projects. And so if you're looking at getting off the ground quickly, you don't have a dev team, or you need some talent in this space, project assistance is available. So Esri is an organization. We have over 5,000 employees. About a third of the organization is dedicated to professional services that really is helping customers get off the ground using our complete system. So we have a lot of talent at Esri. We can help you with that. We work with probably almost 700,000 organizations globally. So we've got a lot of experience across multiple industries. But not only that, we've got an extensive partner network. We've got over 3,000 partners. And a lot of those partners have a lot of talent, actually. We saw one here with Halsey Levine, but there are others that you can work with to really get your project off the ground. So we'd like to leverage our partner network and work with those talented individuals to really get your Unreal Engine-based product and your immersive applications off the ground. So an really important topic there to help you move to the next step. Great. And with that in mind, let's take some questions. So hopefully that was useful. Thanks for joining me through that journey. And we can take some questions. So.